Hello, everyone, and welcome to our professional roundtable. Your audio and your video is muted, and we please ask you to stay that way. You can ask any question you like. You can type it on the chat, and at the end, we are going to answer it. This session will be available on our YouTube channel in a couple of days. And also we have available all the captioning. Thank you. So our professional roundtable today is computer science, and we have two very special guests with us. In a couple of minutes, we are going to present them and we are going to start. But first, we are going to explain to you what is Education USA. So Education USA is a global network of advising centers from the US Department of State. We are all around the world. We are free. All our services are free, and we provide access, comprehensive, and current information about all accredited U.S. higher institutions. Our target are students, higher education institutions, governments, and NGOs. You can follow us in all of our social medias, and also you can find a lot of our information on our webpage, that is educationusa.state.gov. I am going to pass the microphone to my colleague Anna, who is going to present our guests today, and we are going to start this professional roundtable.
Thank you very much, Luisa, and thank you very much to our guest speakers today. I want to present them both. So I'm going to start with Grisha Redder. Is a professional with over 20 years of international business experience, ranging from technology and business consultancy, including consumer electronics and defense industry, specializing in fintech in the past decade, with a particular focus on electronic commerce, blockchain technology, payment processing, e-wallets, high stakes, integration and complex financial services and international remittances. Grisha is a global citizen with US, Mexican, and European passports and fluent in multiple languages. Before moving to Mexico in 2010, Grisha lived in Austin, Texas for 13 years, where he was Director of Sales and Marketing at one of the largest defense consultancies in the US, acting also as key account manager for clients like Apple, Raytheon, Lockheed Martin, and Boeing. Since his return to Mexico in 2010, Grisha has held multiple positions as CEO and country manager for fintech or financial technology companies, and has provided C-suite consulting services for multinational corporations looking to start operations in Mexico and throughout Latin America. Grisha graduated with a bachelor's in science in computer engineering from Tec de Monterrey and obtained an MBA from Baylor University in Texas, and later received several senior management certifications from IPADE, the top business school in Latin America. Grisha, thank you very much for being with us today.
My pleasure, thank you.
And we have Ricardo del Rio. He's currently studying in UPenn. Ricardo is from Guadalajara and studies at the University of Pennsylvania in Philadelphia. His major is electrical engineering with a minor in computer science, a minor in mathematics, and one in engineering entrepreneurship. He is also in the robotics accelerated master program at UPenn. He will graduate with both undergraduate and graduate degrees in May of 2023. During his stay at UPenn, he's done research on current graph neural networks and adversarial machine learning. He's also part of the UPenn electric racing team. He worked at Google in the summer of 2021, doing computer vision as part of a product in Google Cloud. He will work at Microsoft in Redmond this summer in the devices team. He's currently in a semester abroad at ETH Zurich in Switzerland, where his main focus is on hardware for machine learning. His passion lies in autonomous systems and intelligent devices. He loves music, Formula One, and football, and likes to read, run, bike, hike, play tennis, and travel everywhere possible, just like everyone. Thank you very much, Ricardo, for being with us today as well.
Yeah, no, thank you. Glad to be here.
Thank you very much. Okay, so we are gonna start with the questions, and I'm gonna start with Grisha. How did you decide to study computer science?
Okay, so first, just to come clean, I'm actually what we call a computer engineer, which is a little similar to what Ricardo is doing, where you not only focus on programming, but you also understand the cables, the wires, the chips, and the hardware that makes computers tick. And in my case, and I'm gonna have to be very honest here, when I walked up to the university, to Tec de Monterrey in Mexico City, and they asked me, what the heck do you want to study? I did not have an answer in my mind. I had lived prior to that 2 years in Cuba, where I finished my high school. I lived there with my parents, and I didn't learn anything basically in those last 2 years. I had a lot of fun, but didn't learn anything. So I walked up to the counter in the university and they said, what do you want to study? And I said, I have no idea. It's something I have not given any thought. And they told me, well, what does your dad do? And the answer to that question was that he was a computer engineer. And I was like, well, I guess I'll just do whatever he did. And they said, wait a minute. So you graduated in a school in Cuba. You didn't learn anything. How's your math? I'm like, very bad. How's your this and your physics and so on? And all the answers were, I have no clue about any of those. I'm going to have to take remedials for the next year. I had no clue. They're like, look, engineering is very, very hard. Even if you come from a good high school, engineering is very hard, let alone your case where you have no clue. And I'm like, I know, but I can't come up with anything else. Nothing else seems interesting. So I guess I'll just go ahead and study computer engineering. On the day of the induction, where the school actually started, or classes started, and they introduce you to the system and the school and everything else, they basically told everybody in the auditorium, every third person stand up. And I was happy because I was one of the ones that stood up, and I was all kinds of happy and excited, already getting attention. And they said, all of you who've stood up are not going to be here by the second semester, essentially implying how difficult engineering is, and let alone computer science or computer engineering. It turned out to be true that it was very hard, but it also turned out that I wasn't one of the ones that left. I actually pulled through. So but the reality is that to do something like this, there has to be a certain passion. You have to have certain understanding of what you want to do. And in my case, I've been surrounded by computers because of my dad, programming, connecting wires, coming up with experiments, and I had access to a Commodore computer. This is like 50 years ago. It was very basic, both in programming and its capabilities, but I'd always been exposed to computers, so I was passionate about it. And you have to have certain passion and love for it in order to actually put yourself through the rigor of studying this kind of science.
Yes, and I'm guessing you were around 17, 18 years old when you were supposed to decide what you want to do for the rest of your life, right?
Yes, absolutely. I was 18. I started a little late because I moved around so many countries that I lost years in between and then had to make up some time. So I was a bit late. But yes, I was basically 18 and a half when I had to decide what I was going to do, supposedly for the rest of my life.
Yes, we are going to go back to this topic at the end of the session. Thank you very much. And Ricardo, how did you decide to study electrical engineering and computer science?
Yeah, so I guess as Grisha there, I'm also a fake computer scientist, right? Because I'm actually an electrical engineer. So, well, in high school, I was in those technological high schools that exist in Mexico. So I got a degree on automatic control and instrumentation. So I had a lot of exposure to making some processes automatic, especially industrial processes and such. And I thought it was really cool, right? Since I was a kid, I loved to build things. I love to play with Legos and stuff. And then I discovered programming, right? And it's like a really cool way to just experiment and build something. You can see things happening very quickly, and it's very easy to experiment, to see results, to break things and then fix them, hopefully. But then, the important thing was that I like to see things in real life, right? There are many different flavors of computer science, and the one I really liked was this part where you program things that move, right? So that's where I started, leaning into robotics. That's why I chose automatic control in high school as a technological career. We had like subjects in that. And I really liked that, right? So it only confirmed that I really wanted to pursue that path. Then I applied for electrical engineering when I applied to Penn. And then once at Penn, I started exploring more of the programming side of the CS path of electrical engineering, the digital signal processing, which has more to do with analyzing the signals, analyzing information. And I've been leaning more towards that side. Then I discovered machine learning. Everyone's talking about it. So let's see what this about. Learned more and more, and then I started doing research and more, and that's where I leaned more towards computer science, right? So it's a great thing that at least in U.S. universities you don't have to choose since the beginning, unlike universities in Mexico, right? You can combine many things. The good thing is that I knew what I wanted to do, sort of, and there's of course a lot of flexibility already in that. So yeah, it was, I guess, easy in that sense.
And something that we want to know is like, how is that you are studying? Because I think that's requires a lot of work. Your bachelor and your master's at the same time.
Right. Yeah. So there's this special program at Penn. It's called Accelerated Masters. You have to complete 10 more classes whenever you want, right? to get your master's at the normal master's, right? It's usually 2 years because you do research and such. But then if you're an undergrad, you can take graduate level classes. So what I've been doing is taking like one more class per semester, which is a little bit tough, right? Especially when those classes tend to be like advanced engineering classes. There have been definitely some semesters that have been bad. Definitely with the fact that the classes were online during the pandemic, right? So I had, I guess, more time to just like focus on school. That helped in a sense. So yeah, basically just taking more classes and trying to make things work out.
Hopefully, well, it is turning very right. So congratulations, Ricardo. Then I want to ask you, and starting with Ricardo, how would you describe a strong profile for a candidate for computer science studies? What are some extracurricular activities that this candidate should consider in high school?
Yeah, so definitely demonstrate your interest in that, right? So if you like computer science, you probably already built something or experimented with something, right? You explore more of what computer science is. Maybe you've even like, you printed "Hello World" in many different languages or many different times. Maybe you've built something, like a program that maybe does something interesting. Or at least you've explored that, right? So definitely showing that you're really interested in that. I think that's a very strong thing. There's also this thing of as Gracia said in the beginning, right? Math is important. I mean, in the end, you can't treat things as a black box. That's true. Everything can work as okay, so I input this, I get this out, and you can treat it as that. But a strong candidate, right? Someone who's good at things is going to understand what's going on behind it, right? So definitely, I think that's important. It's not going to make or break your candidacy. And yeah, I guess the most important part is to demonstrate interest, right? In terms of extracurricular activities, I guess there are many different competitions that you can take part in. There are virtual competitions, like the Google Kickstarter competitions that are really nice to just familiarize yourself with like programming. That's competitive programming. For some people, it's really fun. Some people find it very stressful. Just like get your hands dirty on programming, right? And it's great because there's nothing expected from you, right? You don't know nothing, right? So you have nothing to lose, and then you can just do all these things, learn a lot, and then just present yourself as a person who's really interested in doing that.
And very specific in your case, when you were in high school, what was some of those extracurricular activities that you were into or you were doing?
Right. Yeah. So I was working for doing different projects for science fairs, right? Science and technology fairs. I remember the first time that I coded something. It was a program that would present you with options of your symptoms when you were sick, right? And then it would say, oh yeah, you're likely to be to have this disease or to be to have a cold or something like that, right? I was like a super simple thing. I learned a lot. I understood a lot of what goes behind that. And besides that, I was also taking part in the physics Olympiads and math Olympiads. Those competitions that were really nice. And I also had a couple of experiences in summer programs during my summer breaks, of course. I went to a program at Yale. It's called the Yale Young Global Scholars. It was great. I got to meet a lot of people, and in that program, there were topics on engineering and applied science and engineering, and also some stuff on bioengineering. So those things were totally external to high school, but really gave me different experiences, right? And I also went to an entrepreneurship summer program later, and I mean, we also were like coding things and stuff. So that was really really cool. But I do have to say that something that wasn't extracurricular was high school itself, and that contained a lot of projects and a lot of things that require you to build things, right? Because it was a technological high school.
Yeah, thank you so much, Ricardo. And Grisha, with all the experience that you have now, how would you describe a strong profile for a candidate that wants to study computer science? You are muted. Yeah, don't worry.
You definitely have to be someone who likes to tinker, who likes to meddle, and who likes to fiddle, and somebody who likes to take things apart. My parents used to hate getting me fancy presents for Christmas or whatever as a kid, because instead of playing with the thing, I would open it up to see how it worked. And if something was missing a light, I would take apart one toy to take out the light and put it in the other. So this is something that you don't learn. This is something that you already have. That level of curiosity, understanding how things work. Why does the TV do that? Or how does the TV know to put a menu at the bottom? Wondering about all these things that are so second nature to us now, whether it's the phone or the computer or a freaking whatever it is. Everything has some sort of brain in it. Everything has a chip in it. I mean, the average car nowadays, even the cheapest car you can think of, probably has somewhere between 20 and 30 computer brains in it. Processors working out all the things. So wondering how those things work and wanting to go in there and understanding what's behind it and how they put it together and why it does what it does the way it does. Those are things that you're born with. This is not something you develop, that level of curiosity. There are tools. Like, for instance, if you wanted to learn one of the most popular scripting languages out there, Python, which is now used for absolutely everything on the planet. I mean, this is whether it's artificial intelligence, whether it's CRISPR, whether it's decentralized finance, IoT, whatever. Python is everywhere. And people who have never thought of being involved with programming are learning it because it makes you that much more powerful. But it's that level of curiosity. So there are websites where it takes you by the hand and step by step teaches you everything about Python. And I think somewhere around the middle of the course, you're either going to figure out that you hate computing, that you hate programming and it's not your thing, or you're going to be hooked on it and passionate. And then you're going to get a Raspberry Pi and you're going to get Lego Mindstorms and we want to program everything under the sun with Python. And that's where you'll realize whether you're the right person for something like this or not. But again, if you're not into tinkering and meddling and fiddling and so on, you're probably not the right person for this. Now, one important point is that generally humans are balanced in terms of the right and left brains, but usually left brain is associated with order, with math, and the right brain is with creativity and arts and so on. All of us use both sides of the brain to different degrees. and there's a question on whether left brain or right brain is better for programming. And the answer is that both are just fine. And whether you're more or the other doesn't make a difference, because if you're into algorithms, if you're into telling computers what to do, and remember, computers don't do what you want them to do. They do what you tell them to do. But that's the left brain. But then there are things that we call UX and UI, which is basically user experience or user interface. And that's aesthetics, that's behavior. That's what the experience is of somebody navigating a website or using a computer or using the iPhone or an app, whatever. That's a right brain. So whichever side of the equation you're on, both add a lot of value to the computer science world. But again, you have to be passionate about it, and you have to find out whether it drives you or not, because forcing yourself to be a programmer, trust me, you're not going to get very far.
Right. Yes, of course. And I want to ask you too, after these years, what are some extracurricular activities that you recommend, and some extracurricular activities that you wish you have done, so you had more like skills for the, for the program, for the studies, for your studies?
Yeah, well, I think, and Ricardo, you can correct me if you think differently, but I think those two platforms that I mentioned are fundamental. Lego Mindstorms obviously is meant for kids. It's not something you program with text language. They use something called graphical programming language, and it's more intuitive because it's cables that you connect to one box and the next and so on, but it transforms into text that the Lego Mindstorm robots then understand. And then the other one is the Raspberry Pi. It's basically a $15 computer that is very powerful. You can do everything with it. It has actuators, it has sensors. You can basically automate an entire building just based on Raspberry Pi. You can create all kinds of robots, and it's very, very simple to program, depending on which language you use. But again, Python is wonderful for that. And I think that when it comes to extracurricular activities, getting involved into something that goes beyond just programming, just creating a website or a program, but actually interacts with real life. This is where artificial intelligence and the Internet of Things comes in. That's the future, the present actually now, but it's the future of humanity. And I think you can no longer stay on just one side of the equation. You have to be able to interact with the real world, whether it's image processing, whether it's motors, actuators, whatever, but doing those kinds of projects because you want to. And what I mean is, hey, instead of buying an alarm system for your house, get a Raspberry Pi and build your own, right? And I think through that, you're going to learn a lot.
And well, that was my third question. So you already answered a little bit of that, but so it says, in order to have an attractive profile for the job market, what are the skills that students need to acquire? You mentioned Python. Are there any certifications that you recommend? What would be the impact of an internship or practical training? And I go with Grisha.
You know what? Certifications are important when we're talking about enterprise level software, when we're talking about something that is maybe security oriented and so on. But when it comes to just getting a job as a programmer, the person interviewing you will find out within the first 30 seconds whether you're a programmer or not. They will find out how passionate you are about this. Of course, there's things like object-oriented programming and structuring and functions and the layout of the programs, and usually what data structures you use. And these are all words that you'll eventually learn and what they mean. But they're not looking for somebody who necessarily knows the syntax of one language or the other. It doesn't matter. In the end, it's the thought process on how you build a program and how you put together an algorithm to solve an issue and how you approach it in something that we usually call pseudocode. Basically, having the mental process of defining how the different entities in your program are going to interact, what each of those is going to consume, what each of those is going to produce, and how you think about solving these problems, what they're looking for. So that's really the profile. Whether or not you know C++, Python, a scripted language, an interpreted language, it really doesn't matter. What matters is how you think about problems and how you solve them.
Yes, thank you so much. Ricardo, can you talk to us about internships and certifications, other type of courses that you've been doing in this program?
Yeah, sure. And then also to add on to what Grisha said in the other question, I also think Arduino is a great platform. It's even cheaper. You can also find another great thing about all these platforms is that you can find everything online. You know, there's always someone who has the same problem as you, and then you can build whatever you want, and it's great. And yes, as for internships, And certifications, I mean, as Grisha said, I mean, he summarized it really well. You know, if you are going to use some corporate software, certifications are great. You know, I mean, they were something that Cisco came out with. You know, you can get certified in many things. I don't think that's super valuable for your first trying to land an internship, right? I think there's they care more in order to get an interview, right? They care more about what you've done. You know, like what's your portfolio? You know, what if you've ever built something, right? If you ever coded something, something that works. You know, maybe like a simple game, even, right? Then after that, it's something that's very useful, and we cannot forget to mention it, is your network. You know, in order to get an internship, at least in the U.S., the people you know, the people you interact with, they you know, they get to know you, and then they can recommend you to better places, to places even that you're more suited for, right? And then once in terms of, you know, once you can get an interview, right, which is like a very hard positive, a very hard thing in itself, right? Richard is totally right. You know, they care more about what you think, and a super important thing, how you communicate. You know, there's this thing about computer scientists and engineers in general. We suck at communicating, right? And that's the truth. We're not that great, right? So it's something, I mean, usually, right? So that's something that it's very important to work on. And usually, at least, you know, in the experiences that I've had in coding interviews, is, you know, you have to explain what you're doing, right? You have to communicate how's your brain trying to tackle this. You know, maybe you have like a first solution, and then you're trying to think, well, how can I optimize this? How can I make it better, faster, to use less resources and everything? Asking for help is also very important. You know, those are the kind of things, you know, those little things that maybe we overlook because we're like super into the technical details, and, you know, how can I make this run 10 times more quickly? But then we forget about, you know, there's like someone who can help you, right? Not like a super omnipotent person who's like on the other side of the interview, right? So that's for internships, and that does like really help to get an internship. And I also have to say that in order to get a full-time job, having internships and experience in industry is also very important.
Yeah, and one topic, if I may, Anna, real quick, is the competition is fierce, okay? The US puts out 65,000 new computer scientists a year. China, 185,000, India, 215,000 engineers. And while the Chinese may not speak English very well, the Indians certainly do. And when it comes to communication, and this is a really good point, when I started off as an engineer, I was very quickly moved to marketing. And I was like, why? They're like, because you can communicate with other humans. And I was like, oh, okay, well, that makes sense. And if you met the standard average engineer type, and we're talking Elon Musk type people here, engineers are not typically known for being good communicators. They'd rather be on their computers and their monitor with headphones on, basically just programming away and everybody leave me alone. And so that competition is fierce, and you no longer have to just have good grades or have experience. You really have to be very, very, very good, because the Googles of the world and the Facebooks of the world, they can get top-notch engineers and get this for very little money. So the average salary in the US for a computer engineer is about $100,000 average. Okay, of course, San Francisco, you'll probably make $500,000-600,000. It's expensive there. But anywhere else in the US, you're probably talking between $80,000 and $100,000. And if they bring people from India or China, they can probably get them for a lot less. So that's another interesting variable to take into account.
Yes, and because of what you are mentioning right now, I want to ask about like job opportunities. Besides working for a company, what are other job opportunities, trends, hot markets, maybe being like a freelance, or how does it work in terms of computer science and this engineering?
Absolutely, the gig economy, working for yourself, being at home, and basically creating apps for the Google Store, for the Apple Store, or basically just contacting large companies. What they do is they take a large project, segment it into pieces. They give you a part that is isolated so you can work on that. You have no idea what that thing does in the great scheme of things, but they basically outsource. So outsourced work gig economy and freelancing is where a lot of the computer science industry and members of that community are gravitating, because they have more freedom. I don't have to tell you that millennials or even Zoomers like their freedom. They don't necessarily look forward to being in an office environment. They'd rather be home in front of their computers. And I think that this gig economy really supports that lifestyle a lot. And I think a large percentage in the next 10 years, maybe over half of computer scientists will probably be working as freelancers in this kind of economy.
Can you tell us more about your specific experience, since you have a very wide experience, and how do you see the market in the future?
Sure. So this is fundamental. Programmers, computer scientists, unlike in the past, will now be used and needed everywhere. Okay. And again, I listed some examples earlier. IoT, Internet of Things. Everything is going to have a computer connected to the internet inside of it. Decentralized finance, that is basically taking normal banking and now putting it up on the cloud and using blockchain technology to facilitate transactions. Bankers are clueless when it comes to technology, but everything is moving in that direction. So having people who know how to program, how computers work, how blockchain technology works, and connecting all these things together securely for transactions is going to be required. Biology, CRISPR, manipulating DNA, improving those tools to be able to do it properly requires computer scientists. And last but not least is AI, artificial intelligence. Everything is gravitating in that direction. You cannot have AI if you don't have speech recognition, if you don't have signal processing, if you don't have image processing, and so on. And for all of that, the only people who can make that happen are computer scientists. So there is not a single area, even poem writing and songwriting, whatever, requires computer scientists and computer understanding. So it's no longer limited to the IBMs or the websites or the Googles. Every single aspect of humanity now requires computers, and therefore requires computer scientists.
Yes, it does. It does. Ricardo, we want to know about, and I remember I hated this question when I was finishing my bachelor's, but what are your plans for the future? And how do you see yourself in, like, let's say 5 years from today?
Right, and also, if I may, there's another big field where you can do things, and that's research. Research drives things. It may not be as sexy as working for a big company, or even like entrepreneurship and that stuff, but research is in the end what powers the industry, right? Being an academic, it's also a possibility. There's people who really enjoy that. They have a lot of freedom to explore many things, and that's also an opportunity. How I see myself in the future. So I'm going to finish next year, right? With a master's and a bachelor's. I'm still deciding if I will be applying for a PhD. Maybe in the UK. We'll see. If not, joining industry. Definitely, hopefully in something related to autonomy. Like autonomous cars, autonomous vehicles, autonomous robots, drones, whatever. I really like that. And then the long-term plan is to start my own thing. I'd like to bring this technology. There's many things about autonomous devices that require structured environments. So things that happen and exist in the developed world, maybe not so much in places like Latin America, right? I believe that there's a lot of opportunity there in terms of technology and bringing it there. So that's the long-term plan, going for, creating a startup, doing something on my own. So yeah, that's my plan for the next 5 years, I guess.
Yes, I think that with what Grisha said, of thousands of people coming out from different programs, it's a lot of competition. So thinking about being entrepreneur or freelance is another thing to think about and consider.
And I mean, and it's already super crowded. That space is also super crowded. There's tons of thousands of freelancers and entrepreneurs, and they fail every day, and that also happens. I mean, it's not an easy world, right? Everything is crowded, especially because we have more and more engineers. Good thing, we need more and more engineers every time, right? So that's it balances.
Exactly. And well, I want to ask you, what would be your best advice to a computer science candidate? And for Grisha, it's specifically for children that are 18 years old and they are thinking about computer science, but they are not really sure. What would you recommend them? What's your advice?
So honestly, it's what I recommended before. Is the first thing is find out if you like it. Okay, there's a certain level of coolness associated with it because, you know, again, there's the Zuckerbergs who are the richest people on the planet, and if I can only be a little bit like him, maybe I can make. Look, it may get to that point. Maybe you'll be successful and create an app that everybody wants to use. It's unlikely to happen, and it is a tough job. It is very complex. Computer systems are getting more and more complicated, and there's these new development techniques where agile, for instance, where you have to collaborate in very short cycles, and you have to actually work with someone else sitting next to you, and you both kind of pitch in, and then somebody else is bitching about your programming style. In fact, you don't comment your code, and it's competitive, it's difficult, it's hard, and it's stressful. You have to find out if you're passionate about it. And again, the only way you can do that is either get some of these platforms that I recommended, get into a computing course. I don't care if it's C++, Python, start with something simple, start with Python, HTML if you want, but find out as early as you can whether you're going to be passionate about it or not. As Ricardo said earlier, in Mexican school systems, in college, you have to define from the first class what you want to do. And changing careers turns expensive, and it really impacts how quickly you can graduate. But in the US, you usually have until your junior year to find out what you want to do. And the average number of times that people change their major is between 2 and 3 in the US. So you can start off as an engineer and end up as a poet or a social worker or a psychologist, whatever. It doesn't matter. In Mexico, it's different. In Germany, it's also different. In Europe, it is. But find out as early as possible so you waste as little time, or either it's because you want to do something else or because you want to get really good programming. And let me say this, if you're 18 and you have never programmed anything in your life, you probably are not going to be a great computer scientist, not because you don't have the capability, but clearly you're not passionate. If you were passionate, you probably would have asked for a computer and would have looked into some level of programming before you turned 18.
Absolutely. And you know what? I don't know if it's a good advice, but something that I advise to my students is that they can take like a 1-year gap and maybe do some internships or ask their parents if they can go to a company and, just really see what they do in that specific field that they are interested in and decide if that's really something that they feel passionate for, then going to the university and studying that program. So that would be my advice, but I want to hear Ricardo's advice.
Yeah, I totally disagree with the last part that Grisha said. I think that if you're 18 and you've never programmed, it's not a bad thing. You can start doing it if you feel that you're interested. I mean, if you're here, there's a reason why you're here, right? Of course, it is important that you know if you actually like it, right? I mean, at some point, like you do need to get your hands dirty, right? There's people whose main topic is not computer science, but then they learn computer science because that's going to help what they want, right? So I encourage you to, like, even in whatever stage you are, to get into this. In the end, no matter what you do in life, it's going to be a great skill to have. But yeah, definitely find out if you like it. As I said, get your hands dirty, work on things, experiment. There's a lot of good tools that you can use, right, to experiment, to tinker around. It's basically free, right? I understand there's also this thing that maybe not everyone has had the same access to resources, or maybe not everyone had like a father like Risha, who is very into engineering and who grew around computers, right? So I think that's one of the main reasons why I wouldn't say that if you're not 18, maybe you've not even been exposed that much to this. Of course, every time more and more we hear about different technologies and everything, right? But knowing that it is possible to learn and to do things, right? That's what I would say. And yeah, just do more. In general, whatever you can I mean, if I was giving this advice to myself a couple years ago, I would say, like, do hackathons, do datathons, do competitive programming. You're gonna suck at first. You're not gonna do great, right? But it's gonna give you a lot of experience, right? And then afterwards, you're gonna be good at what you're doing. And then more importantly, right, you are gonna know if you like it. Grisha has made that point super clear. You need to like it. It's not because your parents want you to do it. It's not because fintech has all the money in the world, and you want to become a quant engineer who moves numbers around, and then you can predict what's the best thing to invest on, right? It's not about that, right? Do something that you like. Get your hands dirty, as I said, and yeah, and find out. There are many different ways you can go in computer science. There are parts of computer science that to me are super boring, and like I would hate my life if I did that. There are parts of computer science that I love. So that's also very important to know, right? To explore it, and yeah, and I mean, Grisha said, yeah, you can change your mind. That's true. In the US, you can do that too. You can even change senior year. Hopefully, you won't do that, right? Because that's also going to be very costly. Because then you're going to have to take like a lot of classes to fulfill what you want. But yeah, that's what it's saying.
And let me correct myself real quick, because we don't want to discourage anyone here. In fact, we want to encourage people to get into STEM, right? Science, technology, engineering, and math. What I meant to say, and thanks for your point, Ricardo, I take it. What I wanted to say is, if you've started programming at 8, like I did, by the time you're 18 and you're still programming, you're there. You're passionate, you know what you want, you know what it means, and you'll probably be awesome at it. If you have never touched a computer for programming in your whole life, it doesn't mean that you won't be good at it. It just doesn't mean, it means that you don't know yet, and you still have to find out. And that's all time that, compared to those folks that started at 8, well, you're kind of a little bit behind the ball. And that was really my point.
Yes, exactly. Thank you very much for clarifying. And finally, I want to ask, with all the experience that you both have, what has been the most fulfilling aspect of, these programs and your experience and about being a computer science engineer? Grisha, if you want to start.
I think it's my connection. Can you repeat that question, please?
Yes. What has been the most fulfilling aspect of being a computer science engineer?
Honestly, it wasn't as fulfilling at first for me. But nowadays, the fact that computer science and understanding computers and programming has such an impact on absolutely everything, and it touches everything, being able to understand what's going on behind the scenes, and being able to, as I said, grab a Raspberry Pi and hack my way into anything or create anything, solve a problem with technology any way I want, and having that power because it is a power. Even I took a class like maybe 5 years ago in ethical hacking, knowing that I can basically hack into anybody's network and get information. I won't do it, but knowing that I can, and again, understanding what's going on behind the scenes is very fulfilling, at least for me. I don't like seeing a process or anything really and not understanding what's going on behind, whether it's how a corporation works, how finances work, how accounting works, how politics works. I'm a kind of person that likes to understand everything about whatever I'm looking at. And so maybe with the exception of the human body, because it's just too much for me. But other than that, understanding these things, and again, this is what drives the world nowadays. That for me has been the most satisfying part of being a computer scientist.
Thank you so much, Grisha. And Ricardo?
So I think I would divide my answer in 2 parts, right? One is, I guess, restating what Grisha said, that personal satisfaction of seeing something working. That's great, after spending many hours seeing that the thing is, failing and failing over and over, and then you finally get it to work. That's one of the best feelings in the world, right? And then the second one is, of course, the social impact that you're having, right? Both in terms of what you're currently doing and the potential impact that you're going to have, right? Hopefully, you're going to make the world a better place through computer science. You're going to impact people positively, and at least that was probably the most meaningful part when I was working at Google, right? Because I knew that I was making a very small change, right? I was optimizing something. but I knew that was going to be used many, many times. That's a great thing to be working at a company that has such a big impact. And in the end, you feel that you're part of that, right? Definitely, you can have different types of impact, right? You can just create a full solution, right? You can integrate a team or whatever. But that impact is really cool and is something that computer science has the potential to do, right? And I think that's also very, very fulfilling.
Thank you so much, Ricardo. This was an amazing roundtable. I, in my personal opinion, I learned a lot about you too. Thank you so much for your time. Now I go with Jenny Diaz. I want to know if anyone here on the session or in Facebook has any questions that they would like to ask. Jenny?
Yeah, hi Anna, thank you. Thank you everyone. It's been amazing listening to you both. And Annie, thank you for leading this interview. We have been learning a lot on the audience as well. We get great comments about everything that you have said. So thank you both for this amazing roundtable. And I'm gonna go ahead and ask the first question I got at some of the audience. And one of them is asking, how the international experience that you both have helped you in this field? Has been helpful or not really?
It's very helpful. From my perspective, being exposed to different cultures and how they think, how they solve problems, and because this is in the end a globalized world, and you will have to work with people from many cultures. Now, whether it's because they're sending you out with customers, with clients, with providers, or because you're maybe in an environment like the US, where you will be working with Indians, with Chinese, with Pakistanis, with Europeans, and in a big melting pot as the US is, having that experience and knowing how to work with other cultures is very, very valuable. I mean, if you have that experience, and also if you speak multiple languages, you will be that guy, the go-to person to send out to a project here and there. So it will quickly help you escalate the corporate ladder if that's what you're interested in, because they want people who can actually work with others well. And again, this is not a normal trait with engineers in general, especially computer engineers, as Ricardo said earlier. But if you are one that actually has that experience and can work with others well and can respect and understand cultures, that will be a big, big plus to your technical knowledge.
And there's also this thing of bringing different perspectives. Having lived in different cultures gives you, the Latin American lifestyle is very different than the American lifestyle, is very different than the Swiss lifestyle here, and that gives you just more different perspectives of how to tackle things.
Thank you, Grisha, Ricardo. And just by listening to you both tonight, we can see that definitely you would add to your profile if you are an international expert and also like working on this field, right? Or studying in this field. I think this would be a following up question also like coming from the audience, like, what would you say would be a good field that you can combine with computer science?
Everything.
Everything. Everything. And really, I mean, again, politics, right? Analyzing voters' preferences, results, tendencies, that's all artificial intelligence, all computer science. So there's not a single field that has to do with humans that doesn't rely on and benefit from computer science.
Yeah, I agree. There's a lot of potential in many different areas. Maybe some that we should ask ourselves if we actually want to touch them. There's a lot of things to do in ethics as well. Ethics and computer science. I think that's something that we're a little bit behind. But yeah, everything is potentially combined.
I love how you both, even muted, were like everything. That was amazing. Okay, and I have another question here. I don't know if you had, but what would you wish you had done different before, if you had something?
Well, I guess as I said, joining more hackathons, right? Even I feel like the environment there is like super chill. You can meet a lot of people. That's also very cool. And yeah, you just do things.
Yeah, more than anything else I could have done, because I went to school from 1992 to 1998. There wasn't much more you could do because it wasn't as wide and interesting as it is nowadays. I guess my only regret was, given my current job as CFO and CEO and all these other things that I do, don't give me or allow me much more time to stay up to date. So as I said, the only thing I can still kind of do is Raspberry Pi and do projects here and there for the house, but I can't. I'm behind the ball, obviously. So clearly my regret is not having more time to do that for fun.
Thank you so much, both. I have a couple more questions before I give the microphones back to Anna. There is one that just arrived. Which field in computer science is best for someone who did just ICT in the high school and other subjects like physics, biology, chemistry, and math? Which field in computer Which field in computer science is best for someone who did these subjects in high school?
I mean, whatever you think you like.
Yeah,
That's the best one.
yeah, I have to agree. It's whatever, again, it goes back to passion, it goes back to what you enjoy. And I would say that's the right answer to that question.
And I want to close with this one before I go back to Annie. Do you think it's too late for me to change my major?
No.
Depends. If you're in the last month of your last semester, yeah, it's a little late. But you know, it really depends on where you are in your career and how much you've already put into what you're doing. But in the end, I think the right answer is if you have the time and if you have the money, depending on what school you plan to go to, if you can change to what you are passionate about, do it. The earlier, the better.
I mean, the earlier the better, but I mean, it's still right after college, it's still earlier than when you're 40 and then you realize that what you've been doing, it's not what you like. So.
Exactly.
Thank you so much.
Thank you very much, Jenny, Grisha, Ricardo. Thank you very much for your time. I just want to share finally. Thank you to all of you that joined today's roundtable. Here you have information about Education USA. If you want to contact us regarding this session or any other session that you are interested in, please send us an email or you can find us in our social media. And finally, we have a really, really good WordPress blog, and it's very interesting. It has a lot of resources for you. So thank you very much, guys, and see you next time. Thank you so much.